Okay. All right. Well, I hope everyone had a chance to take a sort of a short break, and I think we're going to continue. Is Michael Johansen ready? So we'll get back started.
Hey, good morning.
All right, great.
So I'm going to share my screen.
Yep. So yeah, so feel free to take it away, Michael. Thanks so much.
Okay, can you see my slides now?
Indeed.
Yeah.
Great. Okay. All right. All right. Well, thank you everyone for joining this LSIC dust mitigation workshop. I don't think we really expected anywhere near as many participants as we got today. I think Jorge mentioned something like 375 participants or something. I think that's really a testament to what the LSIC, the Lunar Surface Innovation Consortium, really can do and why we established the LSIC. I think that we've got a really great mix of folks from academia and industry and government that are all ready to start discussing the issues associated with the lunar dust and just what we might do about it. My name is Michael Johansen. I am the Technical Integration Manager responsible for dust mitigation agency strategy in the Space Technology Mission Directorate. My role is to establish the dust mitigation strategy, working between the mission directorates, the programs, the projects, to listen to the needs of our stakeholders and develop those concepts and enable folks like yourselves to help us solve the dust problem. What you'll see from me today is an introductory presentation of where we're going and where we've been as an agency and also as the larger lunar exploration community. You'll hear later from other programs within NASA that we all basically work together. You'll hear from Gateway and HLS and others, all in the things that they're doing to try to solve the dust problem. We're going to tell you about requirements and test plans. So in this presentation, I'm not going to focus too much on that. Instead, I'll focus on a few of the recent investments that we've made and how they play into.
Okay, so Michael, are you ready? Are you back on, ready to present?
Yes, I'm sorry. I did lots of things to try to prevent that, but one of the things was not disconnect from my VPN. So which slide am I on? Do you know when I dropped off?
Yeah, if you can just if you want to go ahead and pull it up, and I think you can remember.
Okay.
Yeah, I think you're like into your fourth slide in or something.
Okay.
So, yeah, and we'll try to move things quickly.
Did we talk about?
Yep.
Yep. So, was I talking this yet?
Yeah. Back. Thanks. Yeah. So if you want to just jump to there.
This is yeah, sure. So this is a good starting point. So if I did cut out a little earlier, the point that I was making there is that an integrated strategy includes lots of input from stakeholders, whether you're EVA or HLS or any number of the stakeholders, but it also includes a wide variety of our communities, so universities and so academia, but also industry partners as well. So STMD is doing a number of investments in dust mitigation, and so what I'm showing you here first is the GCD investments. So we have dust mitigation standards, dust mitigation development, and dust mitigation demonstration. In these projects, I'm not sure if you heard any of this, but essentially dust mitigation standards is that high-level agency view. Here's how we handle the dust problem. Here's getting everybody coordinated on the same page on testing with the same standards, and here's what we already know. From the development perspective, we have dust tolerant mechanisms and low dust. So these aren't things that directly go to flight, but ultimately gets infused, or the information taken from it gets infused directly into hopefully future missions. And then on the demonstration side of things, we have electrodynamic dust shield for clips, the CLIPS payload for plume surface interactions, and the patch plate materials compatibility assessment. In this case, we're demonstrating a high TRL dust mitigation technology on the surface of the moon. We're developing a trade study for payloads needed for plume surface interaction. And finally, looking at materials and how we look at the micro scale of interactions with materials with lunar dust actually on the lunar surface. All right. So I also want to mention that, you saw previously the GCD investments, and here what you're seeing are are a couple of payloads that I pulled out. There was a question on how does CLIPS play into this, so I pulled out a couple of payloads. Yep.
Michael, I'm sorry to interrupt.
Oh,
could you possibly turn
Oh,
your video off? Your audio is a little poor quality. Sorry about that.
Okay, no, it's okay. Is this any better?
It sounds a little better, yes.
Okay. Products of working in a virtual world. In this case, we have the regulatory adherence characterization payload, the stereo cameras for the SCOPS 1.1, we're looking at plume surface interactions, and lunar planet vac. These are all CLIPS payloads that we are sending actually to the moon. These are manifested at this point for study and of both understanding dust mitigation protocols, but also understanding the dust a little better in situ. All right. Early stage innovations. So we're getting on to the university piece now of how STMD is making some investments. So we talked previously about bringing into the full university participation for the larger integrated strategy. So the University of Colorado at Boulder and Johns Hopkins University in Baltimore were selected out of a call that we put forward through early stage innovations topic 2, which was the modeling of lunar dust behavior. And what they are looking at is like particle transport between vehicle to vehicle, but also microscale interactions that ultimately feed into a larger scale model. Really interesting stuff there. Glad to have them on board. Another one of the areas that we are investing in is technologies with the university. So we put out a call through NASA's Big Idea Challenge this year on landing dust mitigation, spacesuit dust tolerance, exterior dust cleanup, and cabin dust cleanup. We're looking for universities to design and build and test dust mitigation or dust tolerant technologies that could be used for lunar applications. We recently made that award just, I think, a week ago tomorrow. So here are the universities that are participating in this year's Big Idea Challenge. So I won't go through these for the sake of helping us get back on course, but there are, we did select 7 universities that had some really interesting designs, some things that we haven't seen before, and we're really interested to see what comes of these projects. Of course, so we've talked about university, we've talked about government, but now I want to drive home that we are also including industry as well. So here are 9 investments that we are making currently in industry through SBIR. We see things in upgrading essentially EDS, or looking at solar array coatings. We're looking at, again, at dust tolerant mechanisms, where we're looking at dust proof fluid and gas connectors, for example, or in the filtration community, we're looking for, we're seeing here like cyclone separation, for example, and a wide variety of other techniques for filtration in a cabin or in potentially a spacesuit. But it doesn't stop there, because SBIR goes on continuously, essentially. We have 3 active SBIR subtopics this year in dust mitigation. This year we added a specific topic in dust mitigation technologies for spacesuits, with that selection announcement coming March 18th of 2021. So that's my last slide. The point that I wanted to drive home here, and I hope that you see, is that an integrated strategy looks like where you include universities, when you include industry, when you include government, and you also include all the stakeholders within government to pick up on the pieces that they typically do the best, developing an agency-wide strategy to hopefully solve the dust problem in this case. And with that, I think at the break, I'll take any questions to get us back on track. Thank you.
Okay, great. Well, thank you so much for hanging in there, Michael, despite the technical issues. Okay.